Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So today I'm going to address some frequently asked questions by the knuckleheads in mainstream mathematics academia. So one of the frequently asked questions is this one here. What's wrong with the mainstream definition of the derivative? Well, this person here gives an answer. It says it turns out that they had to change the definition of the tangent line in order to fit with the results of the mainstream derivative. That's true, because the limit calculations are not only complicated, but become strange when they're used in the domain they are not meant for. And the mainstream tangent line at present is not always a tangent anymore. So to accommodate limits, they had to destroy the tangent line. Well, yes, essentially get rid of the original definition. As a consequence, in mainstream calculus, a cubic function x cubed has a tangent at x0, and the other function that you see there has a vertical tangent, but no derivative. So there are inconsistencies with the tangent line and derivative. And of course, when I revealed this in the mathematics Discord server, my message consisting of 2 or 3 sentences stating the facts was deleted by the admins, because it seems they wanted to hide these facts and don't want people to know about the bugs in their rigorous theory. Okay, so all that is true, but I'd like to add to that. This is the only definition of tangent, okay? Later definitions are either wrong or ill-formed. So for example, to say that a tangent line is tangent if the finite difference quotient from either side converges to the same value is circular. Why? Because it depends on the tangent line having its original definition for a short while as well, which is strange because the new definition depends on the original definition. So the finite difference depends on the original definition for the same value from each side, and then magically it suddenly transforms into the bogus new definition. The limit from the left is equal to the limit from the right. But why the hell is that true? It's only true because we assume the original definition of tangent. Okay, pay attention, morons. If you had a function like this, okay, the tangent meets only at one point and crosses it nowhere. If you had a different definition of tangent line, it means that that could be a tangent line too. And if you take the finite differences from both these sides here, they're not going to be the same as this line here. Okay? Do you understand that? So your math professors and teachers are incorrigible idiots. And they, of course, they don't know it because they're arrogant nincompoops. So this reminds me, this gibberish that you see here, which I've just given you as an answer, reminds me of the same in a publication by Neil and Chouard, those two British morons who wrote, and this is what they wrote. They said, dy dx must at least for some considerable time be regarded as an inseparable whole. I wonder how much time, 3 nanoseconds, 50 seconds, whatever it is, just as small delta x is. It does not in any simple or straightforward way mean anything like dy divided by dx. Actually, it does exactly mean dy divided by dx and nothing else. And then they say, and such a statement as this, where you multiply the differentials by cancelling dx, is just so much gibberish. Well, of course, the fucking morons never understood arithmetic, never understood mathematics, never understood calculus. So of course it would be gibberish to them because they're morons. So I've created a little parody which I just have to share with you on their paragraph, which relates to what we're talking about now. So this finite difference, which is the slope of the non-parallel secant line, must, at least for some considerable time, be regarded as a slope approaching that of the tangent line, just as f prime of x is. It does not in any simple or straightforward way mean anything like rise over run. Actually, it means rise over run, you fucking idiots. And a statement such as f prime of x equals rise over run from determining the tangent line slope is just so much gibberish. Sorry, I couldn't resist that. I had to parody these two British morons who wrote this SMP Advanced Mathematics, and I can't tell you how many fine young morons they've produced who have actually gone by that garbage, that utter and total garbage. So you see, what I'm telling you here is that the new, so-called new definition or updated definition uses the old definition. Think about that, Professor Jack Hazinger, you idiot from Illinois State University. Think about that, Professor Gilbert Strang, you deluded moron from MIT. Okay, I get really upset when these incorrigible cranks cannot be corrected. Okay, so the next question is, what is the most important reason limit theory is flawed? The definition of the derivative is circular. Why? Because this mainstream definition means this, you fine young idiots. It says there exists epsilon and delta, both greater than 0, so that given any epsilon, then if this absolute distance here is less than delta, it implies that also this value, this absolute value here, will be less than epsilon. In other words, it falls into, all that is saying is that if you have a curve like this, right, and you have, let's say, C here, and you have the limit here, all it is saying is that if you take a value in this region, in probably the smallest region, then it must fall into this region here, okay? So these are the deltas, and these are the epsilons. All right, that's all it means. It's actually garbage which Weierstrass, that German drunk, came up with, okay? He was an idiot, just like Cauchy and all the others who came before him. So this is, and then get this, L, which is the limit, appears out of the blue. Where did you get L from, you morons? You got it from this finite difference by simplifying it. Okay, so you're using f prime of x in its own definition. By the way, mainstream idiots can no longer refute that, and they admit it. So what they say is, oh, it's perfectly fine to guess L. No, it's not, because in valid mathematics, we do not guess things. We do things systematically, rationally, using common sense and reason, not garbage, like the syphilis that you find in the brains of Dave Explains or some other idiot on YouTube who thinks that he's so bright, but he's just an arrogant nincompoop. Question. Next question. But aren't you dividing the numerator by 0 before you set the denominator to 0 later? No, because in the form f of x plus h minus f of x divided by h, we are referring only to the non-parallel secant line slope. However, in the form f prime of x plus q of x, which we realized from my historic geometric theorem, we are referring to the sum of the tangent line slope and the difference in slopes. So discarding q of xh is equivalent to setting h equal to 0. It doesn't mean we're doing it, but it's equivalent. So, but we aren't saying that this is what's being considered. All we're doing is looking at f prime of x. We don't actually care about the difference in slopes. Therefore, q of xh, which is a difference in slopes, may as well be 0 because it is ignored. In the bogus mainstream formulation, it can only be 0 if f is a linear function. There is no other case. So, dividing by h is never dividing by 0, okay? Even in your bogus mainstream calculus. I'm telling you this now because I've cemented the new calculus, and you can all go fuck yourselves basically, because you're going to have to learn the new calculus, and you're going to have to teach it, and you're going to have to dispose of your limit theory drivel. Okay? So another thing is that the historic geometric theorem, which was from the new calculus, this is what Bing has to say, by the way. Gabriel unearthed a historic geometric theorem, one that exposes the flaws in Newton's and Leibniz's methods. These luminaries, well, they're actually darkies, despite their brilliance, grappled with an incomplete understanding of their own creations. And you'll find that in this conversation I had with Bing. I just asked it one question, and this is where it came up with the answer. Okay? So now, that's just a few frequent questions. Let's look at another one. But then, aren't you just using limits? Oh, this is a typical Marcus Cliver or Zealous Malem question from Sci.Math, or that infinitely stupid idiot Jean-Pierre Massager from Sci.Math. Where do you see the use of limit theory anywhere in the historic geometric identity? Do you see the limit operator anywhere? Open your eyes, you blind morons. Where do you see limit operator in there? Do you see it? For Pete's sake, you're all so stupid, it's unbelievable. All of those terms, these terms, 1, 2, 3, are well-defined slope constants. Nothing is changing. Nothing is approaching anything, and nothing is vanishing anywhere. There are no evanescent quantities a la idiotic Newton or Leibniz, okay? It's all 100% pure geometry, and it takes genius to realize it. And I mean, evidently, neither Leibniz nor Newton nor any of those effing morons who came before me had the intellectual capability. The fundamental theorem of calculus contains limit theory since it has an elongated S, which is Leibniz or Riemann. So this isn't a question, it's actually a comment which is meant to say that if you write integral of an expression dx, any expression here, doesn't matter, then this means you're using limits. Well, let's see the answer to that. So the theorem is stated using ill-formed concepts. So your fundamental theorem is stated using Leibnizian garbage. Correctly, it would be stated using my historic geometric theorem. Did you get that? I said my history, not the fundamental excrement lemma that you find on Wikipedia or some retired ex-professor moron called Folland from Washington State or any other university. I know better, you fucking morons. I know better. Listen to me. As you can see, the right-hand side is expressed as a product of level magnitudes. Okay, oops, that's misspelled. Never mind. It's not magnitudes, it's magnitudes. Also known incorrectly as arithmetic means. The funny thing about an arithmetic mean is that it has nothing to do with the middle of anything or relative position. But again, the idiots of mainstream academia don't know it. So the limit operator appears nowhere here. Okay, so this is the fundamental theorem of calculus in case you didn't notice. Did you notice? Right. The fundamental theorem of calculus is the mean value theorem. What's the connection between this and the mean value theorem? Well, if you divide both sides by h, you have something that's very similar to the mean value theorem. Okay, you have f of x plus h minus f of x divided by h, which is equal to a level magnitude, f prime of c. Okay? Do you understand that? Good. Now, from my historic theorem, we also know that the function which is integrated must be smooth, not like they write on that idiotic article on Wikipedia, that trash pile, which is administered by fools like Arthur Rubin and some old statistics professors, etc., etc. And of course, they're lackeys. So it must be smooth, not just continuous, as the numerous knuckleheads believe. Okay, of course they don't know better, since they have never understood calculus or the facts explaining why it works. Now, those are some pretty frequent questions, and they cover everything that you need to know. I hope you've enjoyed this presentation, that you'll become a subscriber, that you'll click like, that you'll join me on Academia. I'll place a link to my Academia profile, and also that you'll download this new calculus presentation on the Holy Grail, because this is the correction of your bogus mainstream calculus. Of course, the new calculus is far better than this, by the way. It's 100% rigorous. This here is not as powerful and elegant, and you cannot use, for example, the Gabriel polynomial, which is a very advanced concept, in this definition here, and you cannot use a lot of other things which I have not revealed, and you cannot use a lot of other theorems which wouldn't work the same way, except for the final result in your bogus mainstream calculus. I am John Gabriel, and this is the New Calculus channel. Till next time, goodbye.